welcome to this third edition of Eva Media's World of Business Aviation podcast. If you're still with us from the previous two, then we are delighted to have you back. If this is your first time, then thank you. Either way, please do let us know what you think. I'm Paul Eden, editor of Eva magazine, and joining me today I have George Alafinov, who is CEO of Jekta, a Swiss company looking to build a brand new electrically powered amphibious flying boat. Now, if you're on LinkedIn, if you've been looking around social media, you'll see there is growing interest in seaplanes. So I would really like first to say welcome, George, and follow that with, why do you think now is the time for seaplanes?
Well, Paul, thank you very much for having me on this show. I'm very glad to be here to answer your questions and maybe shed a little bit of light on this long forgotten, but not entirely forgotten, a little subsector of aviation. I think before going into why today the amphibian aviation, we believe, is the cornerstone of electrification and a new opportunity for connection of lands and islands and etc. I think it's very important to look at the history of aviation over the last 100 years. Well, we all know the story of Wright brothers that started their flights in the late of 19th century. What is a little bit less known is the huge developments in aviation that were made in the 20s and 30s of the last century, right before the World War II, which of course changed completely the face of the aviation itself. And at that moment, we as a humanity, we had this drive to cover big distances and fly in this new mode of transportation, which was aircraft, which was flying. As the torch was passed from the blips, dirigible. I'm not sure what's the correct term in English.
Talking about airships like the big Zeppelins and the R101.
Exactly. As the torch has been passed from airships to aviation, in the 1910s and 1920s, what was evident is that there was a lack of existing infrastructure, in particular runways all over Europe and United States for the takeoff and obviously landing of the aircraft. And at that time, it only was logical, and is actually logical today, and we'll get to that point, was to use what the nature has already given us, which is the vast bodies of water all over the world as a platform for water bases and a platform for development of the aviation. Of course, this all has culminated in the famous Spruce Goose, the biggest amphibian aircraft or water or aircraft ever built. Unfortunately, this aircraft did not see the light of day due to the end of World War II and financial constraints and other reasons for which, of course, if anybody is interested in a good movie with Leonardo DiCaprio, Aviator, they can take a look for themselves and learn more about that story. So I believe that, and my team, we believe that looking in the past is the way to look into the future. We believe that since there was a huge history of using water as a base for operations in order to connect different places, it is only right to look back into it and see the huge opportunity that it provides especially within the constraints and of the modern world, within the limitations, and I would say new way of thinking in sustainability, in sustainable aviation. It is definitely a very smart choice to look into using water aerodromes or water bases for communication. Going back to history, when we saw the development of the jet engine in the World War II and following the World War II, and of course a massive investment in infrastructure during the World War II for the use of the military operation. After the World War II, we have faced, we as the aviation industry, we have faced a very big resurgence in the possibility of connecting locations through the already built airdromes that were built during the World War II.
Oh.
And certainly with the arrival of the jet engine, there was a certain idea to fly as quickly as possible, as far as possible. Of course, this culminated in the 1960s with the development of the Tu-144 and Concorde, the supersonic aircraft that were not comfortable, not economical, extremely thirsty, and everything was wrong with them except, of course, the speed. And I think this is a very big and a great epitome of where the aviation was leading, faster, 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 to the point where the speed is more important than anything else. Now, of course, when we go into the 21st century, and in terms of the commercial aviation and long distance aviation, overnights, and we have reached certain limits. Right now, we can get in the air in one aircraft and without any stop, go from Europe to, let's say, Singapore, 12-hour, 14-hour flights. That is already possible. Certainly with the modern commercial airliners, which are getting bigger, which is getting a little bit faster, more economical, etc., etc. But right now, in the 2024 and over the last 3 or 4 years, there's been a lot of view on the regional connection for population. As the population around the world grows, obviously in volume, but also evolves in stature in terms of their incomes, and specifically in Southeast Asia, there's a certain need for connectivity of regions, intra-region and inter-region. We're talking about short distance travel. We're talking about up to 800 kilometers, which in the sense of aviation, in commercial aviation, is only 1 hour flight, and not always interesting for commercial operators. So here we are facing with different developments. One development is what I called ultra short, or otherwise called advanced air mobility, which is how to transport people within the radius of, let's say, 30, 40 kilometers or less. And this is where we have eVTOLs coming in, which are fantastic, let's say, substitution or for helicopters that we have had for almost a century now. But what we're talking about is a little bit more than that. We're talking about the possibility for travel 100 kilometers, 150 kilometers, 200 kilometers, 300 kilometers, in that range. And what we're saying is that as the population grows, there would be a huge requirement for the building of land infrastructure in terms of airfields in developed countries, where it's a little bit underrepresented, some parts in Europe as well, and even more so in developing countries, let's say in Latin America, in Africa, in Asia, etc., etc. And this is where we come in and we say, look, instead of investing a huge amount of money into building those airports, especially in the places where the land is scarce and therefore very valuable, plus on top of it, any build of such infrastructure is an irreversible impact on ecology. We say, why? We already have water, which can be a springboard, which can be a base for the aviation, which is sustainable because you don't need to build anything. You don't need anything except for having the infrastructure, how to charge, in this case, the aircraft, or how to provide hydrogen or whatever your solution is. And a simple pontoon to charge and discharge your passengers. So in a nutshell, or to summarize, we are looking into the past in order to think to the future. And we want to take lessons from the past, from those 20s and the 30s, and put them on the modern technology, in the modern environment, and provide the possibility of a sustainable economical travel for developed and developing countries.
So you mentioned speed, and of course your aeroplane won't be fast, but if you're connecting, let's say, a city on the coast with another city where you're landing on its river or a lake, you're perhaps performing a journey in the air that takes 20 minutes, but may take 2 hours in a car or an hour on a train. So for the people traveling, you're still offering them speed. You're still offering them the convenience of taking far less time and getting a nice view from an airplane rather than sitting in the back of a car, of course,
That's correct.
without having to build vertiports for
That's correct.
eVTOLs. Without any of that, you can just fly from the coast to a lake or a river. But because you're an amphibian, you can fit into existing regional networks as well. So this is like the first time in decades where you could actually have a proper regular service from, let's say, we'll imagine this here, the River Thames to Oxford Airport. You can properly connect hard runways and water. It's a whole new level of connection.
That's absolutely correct. And I would divide your question into two, because if we have to divide it, and this is the way we approach things. We look at the developing world where there is no infrastructure.
Sure.
And then on the other side, we're also looking at developed, so-called developed world, which is, in our case, we look at the European Union and United States of America. And though both of those markets have a little bit different specification, and we're trying to build the aircraft that is curtailing for both of them, and we're sure that we can achieve it. And I explain to you why. When it comes, for example, on the developing market, Indonesia, 1,000 islands. Obviously, they have no airports, and there's no connection between the islands apart from boats and ferries. Boats and ferries have a limitation on speed, not only because of the technical limitations of the boats themselves, but also because of the weather. Now here, I think it's pretty straightforward. Let's use amphibian aircraft. Let's use aircraft that can land and take off from the water in order to connect these islands. And instead of using spending 2 hours on a boat, you spend 20 minutes on the aircraft. When we're talking about European Union or UK, and it's very good that you talk about this this example specific, because there is something else that comes into this notion of saving time, and that was something that people don't really look at it. In this particular case, when you're talking about going from London, central London, to Oxford, it's not far away in the map, but it takes hours to get there. Why? Because the congestion of traffic is terrible. The roads are flooded, if that's the correct word. They're overflown with cars, with traffic. Your average speed is I don't know, probably 30 miles an hour, 40 miles an hour, something very, very low. And instead of taking you for 30 minutes from the outskirts of London to Oxford, it takes you 1 hour and a half or something like that. And that's not counting how much it's going to take you to go from the center of London just to exit the city. So it's a little bit different set of problems, but the solution is exactly the same. Instead of spending hours driving in your car, cursing at everybody, road rage, and all the buses and lorries and etc., you come to the River Thames, right in the city of the center. You board the aircraft in your nice suit. You get off in Oxford in 30 minutes, not a wrinkle in your suit. You've had a very comfortable and economical mode of transport from the city center to Oxford. Again, it's simply because the conditions are different. Certainly, UK has a very developed infrastructure in terms of there's a lot of regional airports, a lot of them, unfortunately, forgotten. And this is another side of this medal. It's forgotten because as historically, as the aircraft has become more and more sophisticated, mostly due to safety regulations and correct safety regulations by the regulator bodies, it has become more and more expensive to build and develop the aircraft. Therefore, these costs are relayed on the customer. Certainly, another piece of it, another part of it is that when we're talking about the running cost of any aircraft, there's one thing which is the capex, the capital investment you need to invest into purchase the aircraft, and then there's certainly the operational costs, which comprised of salaries, maintenance, and your running cost, which is of course fuel and oil. And as we know, as we've seen over the last couple of years, those costs are increasing every year. And this is where we come in and say, look, we're not only building an amphibian aircraft that can perform underwater from River Thames to the airport of Oxford, for example, as an amphibian, because an amphibian can operate both on water and land simultaneously with no additional investment, no additional equipment, no nothing. We're also saying we want to electrify it, not for the case of sustainability, but for the case to reduce the cost for the operator, so that the operator have bigger possibilities to sell those seats to a wider range of public, and therefore provide a public service as a mode of transport.
Sure. Okay. So the public is, we hope, looking forward to a future of flying electrically. We've mentioned eVTOLs before, these, for me, electric helicopters, but I know the market sees them as something new and shiny and different. There are people as well talking about conventional takeoff and landing, electric land planes and short takeoff and landing, all that kind of thing. For me, electric motors are magnificent, but there are challenges in supplying the power in terms of batteries. Do you use hydrogen fuel cells? Do you do all that kind of thing? Where does your concept fit into those challenges, if you like, of electrification?
That's a very, very good question. I always remind people that are at least as old as me, whenever we had the change in technology, and the example I bring is the example when we were moving from VHS tapes where we watched our movies to the discs, and we had laser discs and we had DVDs, and there was called the DVD war. So nobody knew which format is going to win. At the end, one of the 2 or 3 formats have won, and the approach is still the same. Now our idea is to have an electric engine, which are obviously simple, economical, and simple in maintenance, etc. But what supplies the electricity to this electric engine? And then there's 2 possibilities. There is, of course, the battery, and then there's the electricity from fuel cells, which transforming a hydrogen or some other substance. Of course, looking at the technologies that are developing right now for aviation, there's a conversation only about the 2, which is a battery powered, which is a much more mature technology, but the technology that at the current I would say level of development is limited, and we know when we're going to face that limit. Nobody else yet came up with a new kind of a super battery that has doesn't have the same problems as the current batteries, which is of course the limit which we're going to face in terms of capacity of the battery. I think that limit is about 400 watts an hour. And another problem is, of course, low cyclage, because the batteries have a limited lifetime, and that they would require a change for a new battery because they're already depleted, and that cyclage is quite low. Both when we're talking about the first aspect, in our case, this limit of 400 watts an hour would be absolutely fine to perform and do most of the aircraft performance and distances that we're looking at. We're talking about probably 400 kilometers of distance. Cyclage is something that a lot of companies work with in order to improve, and there's definitely possibilities to improve that. But here we have to hope and see how the development progresses.
Sure.
But it doesn't mean that we overlook the other possibilities, which is the hydrogen-powered aircraft. There's a huge amount of investments, particularly from the UK, in this technology. There's a lot of what I call movers and shakers that want this technology to succeed.
Yeah.
On paper, this technology provides much bigger possibilities in terms of obviously the cyclage is different. The membrane, fuel cell membrane, is probably 10, 20,000 cycles, so maybe more. There is no limitation. The only limitation that would limit is the physical limitation of the size of hydrogen that you can put in the aircraft for the distances, but the technology is much less mature than the batteries.
Sure.
So in our case, imagine that we're designing the aircraft that can be powered by both, because this about 78% of the aircraft stays the same. We keep the same propeller, we keep the same engine, we keep the same avionics, we keep the same everything. It's just what literally provides the power to the engine, and we have to look at the both, and we see the advantages and disadvantages in the both. We have to see over the course of the next 5 years, as we progress in our development, which of the technologies is going to succeed. My belief, there will be place for both, because if we're talking about a really short range, up to 200 kilometers distances, batteries is enough. If we're talking a much more extended routes, then probably the hydrogen is going to come in.
Yeah. Okay. It's interesting talking about developments and options there. Now, clearly I write lots about this electrification, this kind of thing, and I have some thoughts about the companies in this sector. Now, I know with seaplanes and amphibious aircraft, there are lots of good companies out there. I think there's even a conference coming up later in March in Venice where you're all going to get together and argue about who's best. But it does seem to me as well, there are some companies out there who think that because it's electric aviation, this is I don't know, it's a device. It's like an iPhone or a computer, and it's easy to make it because it runs on electricity and it's got computers in it. So they miss the complications of certification and all of that, which makes so many people fail. So really, quite bluntly, what's your pedigree? Why do you think you can actually build a working flying amphibious seaplane?
Thank you for your question. Now, it's good that you have mentioned Venice. Yes, it's true. On the 20th of March, there's going to be first of its kind, first ever conference of amphibian aircraft. We're talking about almost all the OEMs in the world coming over. We have operators coming over. We have financiers, insurance, the whole spectrum of industries that are looking into this, because there's a huge, more and more with every day we see, there's more and more belief that this is a new upcoming subsector which gonna just explode. And we see that over the last year, that there's more and more and more OEMs. When we have presented our project in November 22, as far as I know, in terms of clean sheet design, we were the only ones. Since then, we have some competitors that are very much developed, like my colleagues from Norway and the colleagues from Netherlands. That's 3. And over the last 6 months, we have seen the resurgence of several more OEMs that are also looking at developing the aircraft, amphibian aircraft, for different purposes. But nevertheless, it's really a very, very fast growing market, because once we looked, the way I look at it is that we looked behind the curtain and we showed behind the curtain for this amphibian little subsector. And now that the people have seen, they see an enormous opportunity that an amphibian aircraft can provide. Because let's not forget, amphibian aircraft can do everything that the land-based aircraft can do as well. Only it can also do the water, which means that the market for it is actually much bigger than people can imagine. Since our aircraft can fly, let's say from London City Airport to Oxford and never touch water at all, and still compete with every other land-based aircraft. But Suddenly, if you want to change your operating paradigm and you want to fly to water, you already have the aircraft for it. And that's a huge advantage for any operator because his hands are untied. So going back to Venice, yes, it's going to be a wonderful occasion to meet all the OEMs, share ideas, and also with a lot of operators that coming in and talking to every single OEM and see what they choose for their future. When we go talking about the development of the aircraft, well, unfortunately, if I wish it would be so easy just to develop the aircraft like it is the iPhone. Although I've never designed an iPhone, I'm sure it's very difficult.
Yeah.
There's two things that come in mind. First of all, it's actually three things to come in mind. First of all, it's you need to understand the market itself. There's section, but subsections. The first thing I would say, what are you looking for in the aircraft as a performance in terms of passenger capacity? Is it 2 passengers, 4 passengers, 6, 19, 20, 55, and why? Why we are looking at the 19 passenger aircraft because we believe this is the golden middle, because it's big enough to be commercially viable, but it's small enough to be able to operate in very limited environment in bays or Amazon River, for example.
Yeah.
Secondly, it's the question of supply. You need a strong, half of the manufacturing of aircraft as the car or as the iPhone, to be fair, is working with suppliers and know how to work with suppliers and who is going to be a suppliers. Now, aviation is actually quite a small industry. There's only limited amount of manufacturers of engines, windshields, wheels, etc. These guys also have limited capacity. So a relationship and knowledge of the supply chain is crucial for it, and this is why it's also part of the challenge of designing the aircraft. And third, last but definitely not least, is experience and certification. As I mentioned before, due to the increased limitations by the regulators in terms of safety, it's very difficult and very expensive to certify the aircraft. It is actually probably more expensive than the development itself sometimes. And you really need to have experience how to certify the aircraft and what is the process, because the process of certification of the aircraft starts before you even design the aircraft. As strange as it may sound. So these are all three very important components when you approach into the design of aircraft. You need to have a clear understanding what it entails and how to approach it. And you also need to have a personnel that is experienced in it. When we come, for example, when we're talking about certification itself, the certification specialists are very rare in this world. For example, you go in the market and say, I want a person who certified an amphibian aircraft before, with experience, with a track record. There may be 5 in the world.
Sure.
And one of them is ours. So it's it's very difficult to approach it in terms of certification, because there's really limited amount of people, and certainly the guys that are working in big companies, Bombardier and Airbus, these big corporations will never allow their specialists to leave, because again, they cannot replace them. So in our for us, of course, all three components are manageable. All three issues are known to us because we have had a huge experience in designing and building the specifically amphibian aircraft. Our team has been working together for the last 20 years, and we have a track record. We have a track record of designing, certifying, and building and delivering amphibian aircraft. And then when I say amphibian aircraft, I specifically talk about the flying boats that we're designing right now. So in our history and track record, we have had a 2-seater ultralight amphibian aircraft that fly. There are many of them around the world, in Europe, in Canada, and certified obviously in Europe, Canada, Asia, etc. And we've had a big experience in designing, manufacturing, certifying the 8-seater so 6-passenger twin engine amphibian aircraft as well. So we have had a huge experience over 20 years. Apart from those 2 certified aircraft, we have designed and built many over maybe another 6 different models of specifically amphibian aircraft, because amphibian aircraft is what we specialize in. Sure. And this puts us in a very I would say specific and very special position, because there's not a lot of teams around the world that have a real track record that can be shown in building amphibian aircraft, and we're one of those teams.
We're running a little short on time, but there was one last thing I wanted to just touch on, which is you've definitely sold it to me. I believe you. I want to buy one, but have you got customers out there? Have you got people who are making commitments? And when do you think we might see one go flying?
Yeah, great question. Thank you very much. We have presented our first time. We have shown to the world what we're doing and why we're doing it. Was in November 2022 in Abu Dhabi Air Show. We believed it was a good time to show to the world that we're here and we're looking into the future with electrification and providing this incredible product for the world. Since then, we have had reached the $600 million worth of orders from various countries. One big order is, of course, from the Indian operator Meher, which is fantastic for us, because we believe that India is going to be one of the biggest markets for such aircraft, and generally one of the biggest markets in the world for the regional air transportation. The reason for that being, of course, they have a huge population, that huge migration within the regions, especially if you look statistically, weekend migration, which means that people are traveling to see their relatives. Family is important in India. They have outdated and overcrowded railway system. Not very developed, let's put it this way, road system. And they also have the will and the desire by the government to develop their waterways for the inter-regional and intra-regional communications connections. And for that, I know for a fact that they're over the last 5 years, they've opened 94 routes, lakes to rivers, rivers to lakes, etc. Specifically for that reason, to give local population the opportunity to get to their destinations much faster and sometimes safer.
Yeah.
But what we have found while talking to the local operators is that the aircraft that are available for them today are simply do not meet the criteria for the operations in India, whether it's an economies or whether it's a window of operations, whether it's technical, whether it's simply because it takes too long to take off and there's not enough place on the water for the operation of the aircraft. So all of this, many reasons why the current amphibian aircraft are failing in India, we're taking in consideration and eliminating them by designing a clean sheet aircraft that can perform fantastically in India.
Yeah, fantastic. Okay, that's been great. Thank you so much, George. I'm afraid we're going to have to leave it there because we're running out of time. So that's it for this third World of Business Aviation podcast. If you liked it, let us know. If you hated it, well, then still let us know, because we'd love to have your ideas. We'd love to know who you'd like us to speak to next. And please do get in touch. Thank you so much.